Yamin Assistant Professor of Zoology from Ustad Bukhari Degree College, Dadi. Dear students, the topic that will be discussed today, that is uptake of water and minerals by root. Water, uptake of water and uptake of uptake of water and minerals by root. Root is the underground part of the plant. Water and minerals, they are taken from the soil to upper plant parts. This process of uptake of water and minerals from soil to upper plant parts, that is called ascent of the shape. Let us see the structure of the root. Suppose this is the central part of the root, and in the center of the root there is xylem. Xylem meaning wood. The xylem of the root, that is enclosed by many cellular layers, and these cellular layers, they are the first cellular layer around the, and dear students, I will show you the structure of the cellular layers around the xylem of the root at one side. The first cellular layer around the xylem is the pericycle. Exterior to the pericycle, there is another cellular layer, that is endodermis. This is endodermis. The second cellular layer is endodermis. Endodermis lies surrounded by cellular layer which is 5 cells in thickness. That cellular layer is called cortex. Cellular layer is cortex. It is 5 cells in thickness. 5 cells in thickness. That cellular layer, 5 cells in thickness, that is the cortex. This is the central part of the root, that is the xylem. Exterior to the cortex, that is epidermis. Epidermis, that is the outermost cellular layer of the root. This is epidermis. If we look on the structure of the root, the outermost layer of the root, that is the epidermis. Inner to the epidermis, and epidermis we know it is a cellular layer which is 1 cell in thickness, and inner to the epidermis there is a cellular layer which is called as the cortex, and the cortex is 5 cells in thickness, and inner to the cortex there is another cellular layer, the endodermis, and we know endodermis is also 1 cell in thickness. Inner to the endodermis there is a cellular layer which is also 1 cell in thickness, that is pericycle, and inner to the pericycle there is xylem, that meaning wood. The flow of the water through the root, that is, first of all, if the water that flows through the xylem, that is upward movement, that is and the movement of water, flow of the water from the soil, that covers you see 8 cells, 1 2 3 4 5 6 7 and 8 cell of the distance is covered by the water, and this movement of the water, that is called a lateral transport, and this is a radial movement of the water. This is a lateral transport. Lateral transport, or this is a radial movement. Radial flow or radial movement. Radial movement of the water, and water from the soil that passes covers about distance of about 8 cells. The some epidermal cells, their membrane is extend outside to form root hair. The root hair, these are the part of, that is root hair. Root hair is the part of epidermis. Some epidermal cells, they extend out to form the root hair. Let us see the epidermal cell, first cell, that is supposed as cell A, and the cortex, the first cell of the cortex is supposed as the cell B, C, D, E and F, and the endodermal cell, that is supposed as cell G, and the pericycle cell is supposed as cell H, and the first cell of the xylem, that will be supposed as cell I. Cell A, B, C, D, E, F, G, H. These 8 cells distance is covered by the water, and this flow of the water covering the distance of 8 cells, that is lateral transport or the radial movement of the water, because water that flows in this direction, this is, you may say, the horizontal direction, when the water reaches in the xylem, now the flow of the water, that is in upward direction, and thus this movement of the water through xylem is called ascent of the cell. The mechanism that is involved in the movement of the water through these you see cellular layers, when the first cell, the root hair, and you see root hair cell and the epidermal cells, which are in direct contact, close touch with the water contents of the soil. Now what happens? The water molecules, they are imbibed by the cell wall of the root hair and you see the other epidermal cells. The process involved in this movement, that is imbibition. Imbibition is the process, first process involved to take water molecules from the soil. The epidermal cells, their root hair, their wall is made up of lignin, pectin and cellulose materials. These are the carbohydrate material, and these materials, they have high capacity to imbibe water, or you may say absorb water. When the water that enters the cell wall of the root hair and epidermal cells, now the water that flows, that moves across the membrane, when the water molecules from the cell wall across the membrane, let us see here in this diagram, suppose this is the plant cell, this is a epidermal cell, this epidermal cell that having a vacuole, this is the nucleus, and this is the cell wall. This is the cell wall which is in close touch with the membrane, but we draw the diagram leaving a small space for our understanding. Suppose this is cell wall, this is cell membrane, though they are in close contact with one another and having flow in space, dear students. When the water that is imbibed by the cell wall, that process is called imbibition, and the water when passes through the cell membrane and enters the cytoplasm, this process of movement of the water molecules pass through the membrane, the process is called osmosis. And the osmosis, after osmosis, the water molecules they diffuse inside the cytoplasm. This process will be called diffusion. That meaning the process, let us see the processes. First process involved, that is imbibition. After imbibition, the second process in the movement of the water, that is osmosis. Osmosis, when water moves, passes through the cell membrane, and after the osmosis, the process is called diffusion. Dear students, though the osmosis is also a special type of the diffusion, and then the water that gets diffused throughout the cytoplasm, including the water that moves towards the vacuole, and plant vacuole, we know they have a hypertonic solution that is called cell shape. Because it's a hypertonicity, the water that can be absorbed by the epidermal cells due to the hypertonic nature of the cell shape. This flow of the water from the soil to the cell, epidermal cell, when this cell, epidermal cell, which is supposed as cell A, this is supposed as cell A. When this cell A that gets filled with water, as a result of absorption of the water by the epidermal cell, what happens? The osmotic pressure of this cell that it decreases, but the water potential of cell A that increases. As a result of which we can say that when the water potential increases in epidermal cell, it means solute potential that decreases, and hypotonicity increases in cell A. And inner to the cell A, that meaning epidermal cell, there is an other cell, the first cell of the cortex, that is cell B. Suppose this is cell B, neighboring cell of the cell A. When the this hydrostatic pressure is developed here in the cell A, as a result of which the water contents they flow from cell A to cell B, involving all these processes. When the water that is left by the cell A are the water molecules which move from cell A to cell B, it means the cell A, the water potential of cell A is reduced, and the water potential of the cell B that increases. As a result of which, in turn, the cell A that will take water from the soil. When the water that moves to the cell B, it means the osmotic pressure of the cell B is reduced. The water potential of cell B that increases, turgor pressure and hydrostatic pressure of the cell B that is increased. And in the same way, the cell the cell B that shifts water from to cell C. In this way, water flows from cell to cell. This pathway is called cell to cell pathway. Because dear students, we know the pathways involved. Pathways involved during the lateral transport. There are three paths. Number one is called cell to cell pathway. Cell to cell pathway. This is cell to cell pathway, and this is a slow pathway, slow mechanism to take water from the soil. And the second pathway, that is symplastic pathway. Symplastic pathway, that is the flow of the water. We know, dear students, we know the cell walls of the neighboring cells, the adjacent cells, they have small pores. These pores are called pits. Through these pits, the cytoplasm of the neighboring cells, they are connected to one another. These cytoplasmic connections are called plasmodesmata. Plasmodesmata. The cytoplasmic connections, they are called plasmodesmata. Now we know the water that flows through the plasmodesmata, this pathway is called symplastic pathway. Yes, students? Symplastic pathway is another pathway to pass water from one cell to the other of the roots. The pathway, the plasmodesmata, the pathway is symplastic pathway is the flow of the water through plasmodesmata. The third pathway involved is apoplastic pathway. Apoplastic pathway. Apoplastic pathway. Apoplastic pathway. Dear students, let it be very clear. The cortical cells, the cells of the cortex, the cortical cells, their cell walls, they are in direct contact. The cell walls of the cortical cells, they are in close contact, in touch with one another, and leaving no any space. The cell walls of the cortical cells, they are connected to one another, forming a continuous column. So, and we know the cell wall of the plants, including the cortex cells, they are made up of carbohydrate materials, the cellulose, hemicellulose, lignin and pectin. We know, including the cellulose, lignin and pectin, they have high capacity to imbibe water. The flow of the water, suppose these are the two cells, flow of the water through the cell walls, water flows taking this pathway, cell wall, and the path of water flow through the cell walls, that is called apoplastic pathway. This is the this pathway is the faster than the other two cell to cell, and you see the symplastic pathways. But here there is a problem. The endodermis problem, meaning there is a demarcation, there is a you see a belt formed by the endodermal cells. Inner to the cortex, we know there is a endodermis, and the endodermal cells, keep on producing a lipid compound. That lipid layer is called Casparian strip. Casparian strip. This Casparian strip is a waxy belt, is a layer, non-cellular waxy layer around the epidermis. This is demarcation, this strip, that is a hydrophobic layer, and the water from the last, eighth cell of the cortex, unable to pass from the last cortical cell, that meaning the F cell, to the cell G, and we know the cell G is endodermal cell. And these two pathways, the cell to cell pathway and apoplastic pathway, they are now not used to cross a barrier. There is only a single pathway, the symplastic pathway is only the pathway to cross the barrier. Here the barrier is the Casparian strip. So the symplastic pathway is only the pathway, symplastic pathway, okay, the flow of the water through cytoplasmic conditions, that meaning through the plasmodesmata. This is only the pathway to pass water from the last F cell of the cortex to the G cell, that meaning endodermal cell. So, dear students, when the water that reaches endodermal cell and using the symplastic pathway, from the endodermal cells, the water and minerals, they are passed to the pericycle. Here the movement of water and minerals from the cell F to G, this is an active transport. Actively, the endodermal cells, they attack water and minerals actively. And when water, after this process, after the endodermal cells, there is a layer, the pericycle. The pericycle, from the pericycle, the water molecules, they move to the first xylem cell, that is cell I, and the lateral transport ends here. And when the water flows through the xylem, this is the ascent of the cell. Dear students, inshallah, we will discuss this ascent of the cell in our next lecture. Thank you very much.